Hello, in this video we're going to look at economic applications of integral calculus. We're going to be finding the integral of marginal cost functions, which we'll see is the total cost function. So a little bit about integration. Integration is finding the original function from the slope or derivative function. So for example, we may have marginal cost, which is a slope function, and we might be interested in finding total cost, which is the original function. So from marginal cost, we can go to total cost through the process of integration. We might also, another example, we might have marginal revenue. Marginal revenue is a slope function. We might be interested in the original function, which would be total revenue. So we could go from marginal revenue to total revenue using the process of integration. So first I'll go through the rules of integration. We'll start with the most basic, the integral of a constant. So the integral of a constant k is just going to be kx plus a constant. One way we can check our answer when we take integrals is take the derivative of our answer, and we should get back what we're trying to take the integral of. So if we take the derivative of kx plus a constant, what would you get? So the derivative of kx is just k, derivative of a constant is 0. So we get back what we were originally trying to take the integral of. So this is one way to check your answer. A few other rules. If we wanted to take an integral of 1, we'd write it like this. And the integral of 1 is just x plus a constant. Again, we can check our answer. If we take the derivative of x plus a constant, what do you get? The derivative of x is 1, derivative of a constant is 0, so we get back what we originally took the integral of. The important integral of a power function, where x is raised to some power, n. The rule is as follows. 1 divided by n plus 1 is going to be multiplied by x raised to the n plus 1 power. And again, we add on some constant. So this is an important rule that we'll use in a little bit. And then integral of a constant times a function. What we can do is we can bring out the constant in front of the integral sign and then just take the integral of this function f of x and then multiply it back through by k. And finally, an integral of sum of two functions, or it could be a difference of two functions. If it was a difference of two functions, this plus sign would be a minus sign. So we can break down the sum of two functions as follows. Take the integral of f of x, then add to it the integral of g of x. Here are a few numerical examples that apply some of those rules. The integral of 3 is just 3x plus a constant. Again, note if we took the derivative of this answer, derivative of 3x is 3, derivative of a constant is 0, so we just get back what we're taking the integral of. The integral of x squared, we're going to use that rule here. N is 2, so in the denominator we have n plus 1. So since n is 2, we're going to have 3 down here. And then following that rule again, it's going to be x raised to n plus 1, where again n is 2. So this will all simplify down to 1/3 x raised to the third power plus a constant. If you were to take the derivative of this result, you would get back x squared. Another example here, we got the square root of x raised to the power of 1/2. Just following that rule, since n is 1/2, it's going to be n plus 1 down here. And then x is going to be raised to 1/2 plus 1. And simplifying that, all of this mess over here is just 2/3. 1/2 plus 1 is 1.5, or 3/2, and we have our answer. And let's look at, you can bring the constant out in front. Here we're going to take the integral of 3x squared, bringing the 3 out in front, taking the integral of x squared, which we already saw over here actually. We have this, and that just simplifies to x raised to the third power. We got 3 divided by 3, so all of that cancels to 1, so we're just left with x raised to the third power plus some constant. One thing to note here, this 3 is multiplied through by this constant, but that's really inconsequential. 3 times a constant is just an arbitrary constant, so I'm just calling it a constant. Okay, so no big deal. And again, we could check our answer. If we were to take the derivative of this result down here, we get 3x squared. Derivative of a constant is 0, so we get back what we're trying to integrate in the first place. And now some economic applications. So here we have marginal cost, which we know is a slope function. The original function is total cost. So if you take the derivative of total cost, you get marginal cost. So now we're kind of doing the opposite, the antiderivative. So we want to go from marginal cost to total cost. And in fact, what we'll do here, we'll find all the firm's cost functions. So integrating 10, we get, from our rules, we're going to get 10q plus the constant. So that's what total cost equals. So total cost equals 10q plus a constant. Variable cost is just the part right here, 10q. This constant here is just fixed cost. If we wanted average fixed cost, we would take the constant or fixed cost divided by q. If we wanted to get average total cost divided by q. So 10q plus constant all divided by q. Simplifies to this. The 10q divided by q is just 10. If we wanted to get average variable cost, we would take the variable cost equation and divide it by q, which in this case would just give us 10. And again, we can double check our math here. If we take the derivative of total cost, we will get marginal cost. Okay, and that's just 10, and that's what we started the problem with. All right, let's do a slightly more complicated marginal cost function. Here we're going to let marginal cost equal 5 plus 2q. And as before, we'll find all the firm's cost functions. So taking the integral of 5 plus 2q, we're going to write it like this. I'm going to break this into basically 2 functions, the 5 and the 2q, realizing we can bring the 2 out in front of the integral sign here for the 2q part. So the integral of 5 is just 5q. The integral of q, and again following that rule, note here q is raised to the power of 1, so n equals 1. So we got n plus 1, where n is 1. And again, following that power function rule, n plus 1, where n is 1, it's going to all equal this. And that will very nicely simplify to just q squared. So we got 2 divided by 1/2 q squared. So simplifying it down here, that now becomes our total cost equation. So total cost is a constant, fixed cost plus the variable cost part. So variable cost is 5q plus q squared. Fixed cost, as before, nothing too interesting here. Average cost, just taking the total cost equation and dividing it through by q. Simplifies to something that looks like this. Average variable cost, just taking the variable cost equation and dividing it through by q. We get something that looks like this. And again, note here marginal cost. If we were to take the derivative of total cost, you'd get 5 plus 2q, and that's what we started this problem with. All right, and a slightly more complicated marginal cost function, which will be our last example. If marginal cost equals 10 minus 4q plus 3q squared. From here, we're going to integrate it, get the integral to find total cost, and then go from there. So first writing the integral of 10 minus 4q plus 3q squared. Breaking this down into, basically sums and differences. So we got the 10 part over here. We got the q over here. I brought the minus 4 out in front of the integral sign. We got the q squared over here. And again, the one rule allows us to bring the constant out in front of the integral sign, so we do that. So the integral of 10 is just 10q. The integral of 4q is going to be given by this. Okay, so going to get that. And then the integral of 3q squared is going to be given by this. And we're going to just add on a constant here at the end. And now simplify. So 10q, 10q. We got minus 4 divided by 2. So that's minus 2q squared. We have 3 divided by 3, so that's just 1. And then we got q raised to the power of 3, and then the constant. So this total cost, so from marginal cost, we go to total cost. It looks like this. And then on the, getting the remaining cost functions, I didn't do fixed cost or average fixed cost. That is basically unchanged from all the other examples. But variable cost here will look like this. Average variable cost, just dividing variable cost by q. So 10q divided by q is 10, minus 2q squared divided by q is this. And q cubed divided by q is just q squared. And then average cost would be given by this equation here. And we could double check our answer, is the derivative of total cost. Does it indeed give us this marginal cost equation? So the derivative of a constant plus 10q minus 2q squared plus q cubed does give us this. So the derivative of 10q is 10. Derivative of minus 2q squared is minus 4q. And the derivative of q cubed is 3q squared. Derivative of constant is 0, so it doesn't show up in marginal cost. So I hope you found this video helpful.